Hey everyone, welcome back to the channel. Today we're diving into Python classes where we'll explore grouping data, instance methods, class and object instance types, and class constructors to build more efficient and reusable code. So let's get started. First, we discuss the concept of classes grouping data. Multiple variables are often closely connected and should be combined into a single entity with multiple components. For example, instead of handling separate variables like hours and minutes, they can be grouped into a single variable called time. The class keyword in Python allows us to create custom objects that store related data and functions, making code more organized and efficient. In Python, a class is created using the class keyword, followed by a name. Its body contains variables and methods that define the class's attributes and behavior. The general structure of a class is given. Each statement inside the class defines a property or a method that helps in structuring the object. This approach ensures that related data and functions are bundled together, improving code reusability and readability. In Python, a class serves as a blueprint for creating objects that group related data and functions. Each object created from a class maintains its own attributes, which define its state and behavior. In the given example, the time class is defined to represent a time of day. It contains an initializer method, which is automatically executed when a new object of the class is created. Inside this method, two attributes, hours and minutes, are initialized to 0, ensuring that every new time object starts with these default values. This structure allows us to encapsulate related data within a single entity, making it easier to manage and manipulate time related values efficiently. In Python, instantiation refers to the process of creating an object from a class. In the given example, the time class is used to define a blueprint for representing a time of day. When we create a variable myTime using time, an instance of the class is generated with default values of 0 for both hours and minutes, as set by the init method. After instantiation, we manually assign values to the object's attributes. My time hours equals 7 and my time minutes equals 15, updating the object's state. The print statements then display these values in a formatted output 7 hours and 15 minutes. This example demonstrates how objects allow us to store and modify related data efficiently while keeping it encapsulated within a structured format. In Python, attribute reference allows us to access and modify the attributes of an object using the dot notation. In this example, the time class is defined with an init method that initializes two attributes, hours and minutes, both set to 0 by default. When the statement myTime equals time is executed, it calls the init method, creating an instance of the time class named myTime with its attributes myTime.hours and myTime.minutes initialized to 0. Using the dot notation, we can reference and modify the object's attributes. In the next steps, myTime.hours equals 7 and myTime.minutes equals 15. Assign new values to the respective attributes. Finally, when printed, the program outputs 7 hours and 15 minutes. This example demonstrates how attributes of an object can be accessed and modified using the attribute reference operator, a fundamental concept in object oriented programming. In Python, a class instance represents an individual object created from a class blueprint. A programmer can create multiple instances of a class, each with its own unique attribute values. In this example, the time class is defined with attributes hours and minutes, both initialized to 0 using the init method. The program first creates an instance of the time class called time1, then assigns it values 7 for hours and 30 for minutes. Another instance, time2, is then created separately and assigned different values, 12 hours and 45 minutes. Each object maintains its own state, independent of others. Finally, the print statements display the values of time 1 and time 2, resulting in the output 7 hours and 30 minutes and 12 hours and 45 minutes. This example highlights the concept of multiple instances, where different objects of the same class can hold distinct data, making object oriented programming a powerful approach for managing structured data efficiently. Now that we've explored the fundamentals of classes and how they group data, it's time to test your understanding. Let's dive into some quick questions to check your understanding. Take a moment to think about your answers and drop them in the comments below for me to review. Alright, here comes your first challenge. Think about how we organize related information in programming. Can a class be used to group related variables together? Think you've got it? Drop your answer in the comments below and let's see who can get this one right. Here comes your second challenge. When you create an object from a class, something special happens behind the scenes. Does the init method get called automatically? Take a shot at it and share your answer in the comments below. Here comes your third challenge. After executing t equals time, do you think t is now referencing an instance of the time class? Take a moment and lock in your answer. Review your answers and compare them with the concepts you've studied. Let us know in the comments how many are correct and how confident you feel about your understanding of the material. Next, we move to the concept of instance methods. In Python, a function defined inside a class is called an instance method. These methods operate on individual objects and can access or modify their attributes. An instance method is invoked using dot notation, allowing objects to perform specific actions or return values based on their data. In Python, a class can include user defined functions, also known as instance methods, which operate on the attributes of an object. In this example, the time class is defined with an init method that initializes two attributes, hours and minutes, to 0. Additionally, a user defined method, printTimes, is created to display the values of these attributes in a formatted manner. An instance of the time class, time1, is created and its attributes are assigned the values 7 for hours and 15 for minutes. The method printTime is then called using dot notation, which prints the values of time 1 hours and time 1 minutes. The output of the program is hour 7 minutes 15. This example demonstrates how instance methods allow objects to perform actions, making classes more functional and dynamic. Now that you understand instance methods, let's put your knowledge to the test with some practice questions. Take your time to think through each one and don't forget to share your answers in the comments below. Here comes the first question. Imagine you're working with the animal class. How would you create an instance of this class and name it cat? Think carefully and write your statement. Here comes next question. Every instance method in a class needs a special first parameter to work correctly. Do you know what it is? Drop your answer below. Review your answers carefully and compare them with the concepts you've studied. Share in the comments how many you got right and how confident you feel about your understanding of the material. In the given program, an employee class is defined with attributes, wage, and hours worked, which are initialized to 0 in the constructor init method. However, the mistake occurs in the definition of the calculate pay method. The programmer forgets to include self as the first parameter of the method. When an instance is created and calculate pay is called using alice.calculatePay, Python internally passes the instance as an argument. Since calculate pay was defined without any parameters, this leads to a type error, indicating that it takes 0 positional arguments but 1 was given. This error demonstrates the importance of explicitly including self as the first parameter in instance methods so they can properly access and manipulate object attributes. After understanding the concepts of methods definitions, let's put your understanding with some practice questions. Think through each question carefully and then share your answers in the comments below for me to check. Let's see how well you've grasped this concept. Alright, here's your first question. How would you complete the definition of the add method in the myClass class so it sums up self.x and self.y without any extra parameters? Think carefully and share your answer in the comments below. Check your answer to ensure it aligns with what you've learned. Share it in the comments and see how well you've understood the concept. Here's your second question. Can you complete the definition of the print time method in the time class so that it takes a parameter GMT and adjusts the time accordingly? Let's see your solution in the comments. Take a moment to double check your answer. Does it reflect what you've learned? Share your response in the comments and let us know how confident you feel about it. Now let's delve into the concept of class and instance object types. In object oriented programming, a class object acts as a blueprint for creating instance objects, each with unique attributes and behaviors. When an instance is created, the init method initializes its state. Class objects define shared properties and methods, while instance objects store individual data, ensuring code reusability and organization. The given program illustrates how the init method in the time class initializes instance objects, setting default values for their attributes. The program begins by defining the time class with an init method that initializes two attributes, hours and minutes, both set to 0 by default. When an object of the time class is created, these attributes are automatically assigned these initial values. Next, two instance objects, time 1 and time 2, are created from the time class. At first, both objects inherit the default values set in the init method. However, their attributes are modified afterward. Specifically, time1.hours is updated to 5 and time1.minutes to 30, while time2.hours is assigned 7 and time2.minutes is set to 45. The program illustrates how instance objects time 1 and time 2 are created from the time class, each maintaining independent attributes. The global frame stores these instances, ensuring modifications to one do not affect the other. This program demonstrates object oriented principles by allowing multiple objects to share a class blueprint while preserving unique attribute values. The init method initializes default values, which can be updated as needed. This program demonstrates the concept of class attributes, which are shared across all instances of a class. The marathon runner class has a class attribute racer distance set to 42.195, representing the marathon distance in kilometers. Unlike instance attributes, which are unique to each object, class attributes are stored in the class itself and accessed by all instances. When runner 1 and runner 2 are created, they do not have their own race distance attributes. Instead, they reference the shared attribute from the marathon runner class. The print statements confirm this behavior by accessing race distance through both the class and individual instances, yielding the same value in each case. This illustrates how class attributes provide a common value accessible to all instances, ensuring consistency without redundancy. This program illustrates the concept of instance attributes, which can hold unique values for each instance of a class. The marathon runner class defines a class attribute, race, distance, shared among all instances, and an instance attribute, speed, initialized to 0 within the init method. Unlike class attributes, instance attributes belong to specific objects, allowing each instance to store different values. In this case, runner 1 and runner 2 are created as separate instances of marathon runner. Their speed attributes are then individually assigned values of 7.5 and 8.0, respectively. When printed, these values reflect the distinct attributes of each instance, demonstrating that instance attributes are independent and can vary between objects while still maintaining access to shared class attributes. This program demonstrates the concept of class and instance namespaces, showing how attributes are stored and accessed in object oriented programming. The marathon runner class defines race distance as a class attribute, meaning it exists within the class namespace and is shared by all instances. When runner 1 and runner 2 are created as instances of the class, they initially contain only instance attributes, such as speed, in their respective namespaces. However, when runner 1 point race distance or runner 2 point race distance is accessed, Python first searches for the attribute in the instance namespace. Since race distance is not defined at the instance level, Python looks in the class namespace and retrieves the shared value 42.195. This behavior ensures that all instances have access to class attributes unless overridden within an instance, demonstrating how Python searches through namespaces using dot notation. Alright, now that we've explored class and instance object types, it's time to put your knowledge to the test with some practice questions. Take a moment to reflect on each question and then share your answers in the comments below. Let's find out how well you've grasped this concept. Here are the questions. Fill in the blanks with the correct terms related to class and instance objects. Think carefully and drop your answers in the comments below. Can you get them all right? Let's find out. Review your answers carefully and match them with what you've learned. Share your answers in the comments. Let's see how well you've grasped the concepts. Let's explore the concepts of class constructors. A class constructor is a unique method designed to set up objects when a class is created. In Python, the init method acts as the constructor, assigning initial values to attributes. By using constructors, objects can be initialized with default data, enhancing code structure and reusability. This program demonstrates how to add parameters to a class constructor in Python. The racetime class includes an init method that takes three parameters: start time, end time, and distance. These parameters are used to store relevant details about race contestants, such as the time they started and finished the race and the total distance covered. When instances of race time are created, such as time Jason and time Bobby, specific values are passed to the constructor, which assigns them to the respective attributes. This approach allows for more flexible object creation, ensuring that each instance contains meaningful data from the start, improving code clarity and efficiency. This program demonstrates the concept of constructor default parameters in Python. The employee class defines an init method that initializes an employee's name, wage, and weekly work hours. By default, an employee is considered part time, working 20 hours per week at a minimum wage of $8.25 per hour. If specific values are not provided during object creation, these default values are assigned. The program creates three employee instances: Todd and Jason, who use the default parameters, and Trisha, whose wage and hours are explicitly set to $12.50 per hour and 40 hours per week, respectively. The list employees stores these instances, and a loop calculates and prints each employee's weekly earnings. The output confirms that Todd and Jason earn $165.00 per week, 8.25 multiply 20, while Trisha earns $500.00 per week, 12.50 multiply 40. This approach simplifies object creation while allowing flexibility for customization when needed. Now that we've covered the concept of class constructors, it's time to put your knowledge to the test. Let's dive into some quick questions to check your understanding. Think carefully and share your answers in the comments section for me to review. Here comes your first challenge. Imagine you're designing a class that needs to store two values, x and y. Your task is to define an init method that takes these parameters and initializes them. Can you get it right? Here comes your next challenge. You have a class widget that needs two parameters, p1 and p2, upon creation. Can you complete the statement to create an instance with p1 equals 15 and p2 equals 5? Think carefully and share your answer in the comment section. Review your answers carefully and compare them with the concepts you've studied. Let us know in the comments how many are correct and how confident you feel about your understanding of the material. In conclusion, we've explored the fundamentals of class and instance objects. You've learned how classes act as blueprints, how instance objects maintain unique attributes, and how class attributes are shared across instances. Through detailed examples, we've seen how namespaces work and how attributes can vary between instances. Understanding these fundamentals is crucial for mastering object oriented programming, as they form the backbone of building scalable and efficient applications. Keep practicing, challenge yourself with new problems, and don't forget to share your thoughts and progress. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. Thanks for watching.